In today's lesson 6.3, you'll be adding, subtracting, multiplying, and dividing functions. On the left-hand side, I have basically what the format would look like, and on the right, we're going to try a subtraction example. So from f of x, we're going to subtract g of x. So we're given f of x is equal to 3x raised to the power of 1/2 plus 4, and our g of x is negative 2 to the 1/2 minus 2, and we're subtracting those. And because it's subtraction, remember we're going to have to either distribute the negative, or we can say add the opposite. So add the opposite, and then we just combine like terms. So 5x raised to the power of 1/2, and we have a plus 4 and a plus 2, so plus 6. So that would be f of x minus g of x. But then it's going to ask you about the domain. So when we're identifying the domain, we need to determine if there's a denominator or if there's an even root. So we're going to review a little bit regarding domains. Our two main concerns when dealing with domains is there an even root and is there a denominator? And the square root of x plus 5 is even because we could put our little 2 there. So we need to set whatever's underneath the radical equal to 0. So x plus 5 equals 0. Subtract 5 from both sides. X equals negative 5. So our domain for this particular example, x has to be greater than or equal to negative 5. Any value that's less than that is going to create a value that's not greater than or equal to 0, and it has to be greater than or equal to 0 underneath the radical. Our next example has a denominator, and we know the denominator cannot be equal to 0. So if we solve for x squared minus 16, it would be x squared equals 16. We add 16 to both sides, take the square root of both sides, so x equals plus or minus 4. So in this instance, our domain is going to be all real numbers except it can't be a positive or a negative 4. Those two values would make the denominator equal to 0. This third example, we have an even root, so it says x is greater than or equal to 0, but it's also in the denominator, and we know we can't have a denominator of 0. So the domain for this particular example is going to be x has to be greater than 0. We cannot include the equal to bar. This final example concerning domain shows that because there's no denominator and the root isn't even, it's odd, that our domain will be all real numbers. Now we'll go back to looking at more function examples. Okay, let's try a multiplication example. So instead of writing f of x, it says f of x is equal to 8x times, and our g of x is 2x raised to the power of 5 over 6. And remember, x to the 1 is the same as 6 over 6. So we can multiply 8 times 2 is 16x, and then 6 plus 5 in the numerator is equal to 11 over 6. Now we need to consider the domain. Because we have an even root, that means our domain says that x has to be greater than or equal to 0. So that's going to be all non-negative real numbers. In this next example, we're going to use our same f of x and g of x, but we are dividing, and I started it. So 8x, and again, I'm going to put 6 over 6, but now we end up subtracting the x's, so it's x to the 1/6, and then 8 divided by 2 is 4. Again, we need to consider our domain. So we have an even root. So that tells us x is greater than or equal to 0, but it's in the denominator. So if it's in the denominator, it cannot be equal to 0. So it has to be x is greater than 0. So that would be all positive real numbers. Composition of functions. So now we have a function within a function. So we're going to put in an x, and that x is our domain. And when we put it in our little function machine, out comes f of x, and that would be our range. But what happens is the range becomes the domain of our next part. So now we're going to input that value, and out comes our g of f of x. Let's look at a couple examples, and it'll help clear it up a little bit. Okay, this is similar to your standardized test practice example from your textbook. So it says f of g of -3. So instead of the x, we're putting in a -3. So g of -3 equals -3 squared minus 1. That's this. And instead of the x, we put in the -3. And when we work that out, we get 9 minus 1. And that is equal to 8. So now instead of in here having g of -3, we're going to replace that g of -3 with the 8. So it's f of 8 equals, and we go up to the f of x. So 3 times 8, oops, really messed that up. 3 times 8 minus 4, 24 minus 4, so our final answer is 20. All right, we're given our two functions, and we're going to find g of f of x, and we're going to start from the inside. So we have our g, and then instead of the f of x, we're going to put in 2x plus 3. So now this value is going to nest in the g of x. So it's actually going to be the 3 in the numerator, and then instead of the x, we're going to have 2x plus 3 plus 1, and that simplifies to 2x plus 4. I thought we should try one with a negative exponent. So again, remember we start from the inside, so it's really, and then instead of g of x, we're going to write 4x plus 5. So now we're at our f of x. So this x is going to be replaced with 4x plus 5. So it's actually 4x plus 5, and then that x quantity is raised to the power of -2, and we know that that sends the expression to the denominator, 4x plus 5, that quantity squared, and the 6 is not raised to a negative power, and that just remains in the numerator. The last thing I'm going to point out, and you may have noticed it when we were working through the problems, sometimes the f of x is on the inside, the g of x is in the inside. Sometimes you'll see it's g of x. You'll see some of those in your homework problems, so don't get hung up on it just looking one specific way.